Good afternoon, everyone. This is David Fries from Titan Cloud Software. Thanks for joining. I know we were giving some folks time to join. We have a pretty good attendee list right now, over 30, I think. So let's get going. So today we're going to talk about the next generation of fuel analytics, seeking the perfect gallon, which is a product category here at Titan. I'm going to review the agenda, introduce myself and my chief data scientist, and then we'll go through the content. Please, questions, we'll handle questions at the end. So please, as we go through it, just, I think you can actually, via Zoom, you can ask the questions. We have some moderators going to be taking a look at those. So, quick agenda about Titan, for folks that don't know us very well. Talk about our platform. The core of the session today is about the fuel analytics. We're going to talk about wetstock management and perfect gallon high definition. We're going to talk about fueling experience analytics. We're going to talk about our emerging R&D and products and forecasting, fuel forecasting. We're then going to demonstrate it. I have Clay Moore here, who's my product manager, one of my senior product managers, is going to go into the product and actually show you customer results. We've changed the name to protect the customers, but this is actual data from actual customers. And then we'll take questions and answers. So, again, I'm Dave Fries, CEO, but more importantly, I'm Chief Product Officer. That's my function today, focused on building the best products I can, create the most value, the most differentiation. My background, started as a computer engineer, building huge technology systems, financial consulting, early kind of architect in the world of expert systems and rules engines and what's now called machine learning. Became a product, focused on product development at places like McKinsey. Also spent a number of years managing large technology organizations at Siebel Systems and Oracle. And I've been here at Titan for about 10 years. At Titan Cloud, we launched in 2012, 2013. And I've known Kurt Gutzman for about 20 of those years. Kurt, why don't you kind of go into your background?
Yes, thank you, David. It is about 20 years now, and David and I have worked together successfully, not just at Titan, but at a few other places as well. And David has experience going back in machine learning when he was CEO of Gen 5, which was a support vector machine marketing analytics company. So David has chops as an engineer. He's got a degree in computer engineering as well as an MBA. So we make a pretty good team. And I've been working in the areas of engineering, computer software, networks, machine learning for quite a long time. I hate to tell you how old I am, but machine learning isn't really something new. I was one of the first people to publish a paper on neural networks in 1987 in the first international conference on neural networks on how to solve NP-hard problems with a priori design of neural networks. And it's been going on since then. For much of the last 20 years, I've spent finding fraud in financial data, like credit card transactions, internet banking, that kind of stuff. Some of these are human attacks, others are automated attacks. I'm actually the holder of 2 patents on cybersecurity related to internet banking, and those have been really very interesting by themselves. And that application in these very large data sets, and we're talking millions and millions of these things, and you're looking for a few needles in the haystack, is served really well at Titan also. And some of my experience in high-performance computing bears on this as well. I've worked at the Advanced Computer Research Institute in France, building the great French supercomputer, also at NASA on the International Space Station, and also at planning research on hypercube architecture computers. And so what we see today is that machine learning sounds like a new word, right, or artificial intelligence. They're really not. They've been around a long time, but what is different now is that we have the data collection capabilities and the computing power to make things that used to be infeasible feasible. And so what we're doing here at Titan now is we're taking these new capabilities, not so much new methods, but new capabilities enabled by networking and computing architectures available to us, particularly through Amazon, where we host our infrastructure, to deliver superior analytics for you in the area of analyzing what goes on in a fueling system. And there's quite a bit to analyze there, and it's a very rich system in terms of data. So I've come on board as the chief data scientist in the last year with Titan to devote my full time and attention to this. Previously, I had developed the world's fastest polling engine for Titan as a consultant to the company over 10 years ago. We're still using that polling engine successfully to collect all the data from literally thousands and thousands of ATGs every minute of every day. Thank you, David.
Thanks, Kurt. So I play a data scientist on TV. Kurt's the real deal. So let's go into the background of Titan. So for those who don't know us, we're a focused cloud software company. We have the one code base, multiple tenant architecture, week releases. So we're pretty agile. Our customers know that. We move quickly. We're focused on customer fueling experiences, minimizing fuel variances, and our legacy and our legacy product focus was environmental risk and costs and reducing and eliminating those risks and costs. You know, you can see the stats in the middle of the page here. 50,000 sites monitoring, 12,000 inspections, 10,000 users. I would say for the product markets where we compete, we are the leading and dominant cloud software platform. Our customer, this is a very small list of customers, but we service a wide variety, fundamentally targeted on the largest retailers. So we have 5 of the top 6, the largest fleet companies, so on and so forth. But we've also, all sizes work. I think, we're able to basically expose functionality based upon whatever customer use case is important to them. Not everyone has, 5,000 sites, works for 500, works for 50. That's the nature of software. So we have a lot of rich functionality that we can dial down as needed depending upon your specific situation. The next the kind of key use cases for the products. So environmental, it's really about reducing releases and the cost of those releases, which is found in your balance sheet, environmental reserves. Obviously, regulations are enormous, making sure you have full compliance of that. We also have a use case around reducing vendor costs by having a common data platform, APIs. You can manage the vendors more efficiently. They don't control the data. They don't control the testing schedules. So we see our customers getting 15 to 30% savings there, which is pretty good amount of money. On the fuel cloud, which is we're going to talk through today in more detail, we're eliminating variance from your system. We're 30 to 90 basis points. Frictionless fueling experience has a really incredible ROI as you basically are selling a few thousands more gallons more per month per site. Let's say 2 to 6% increase in throughput, which has an enormous impact. And then fuel supply, we have some innovations in how you manage inventory to how you control inventory and how you use kind of this data, this kind of real-time data stream to kind of improve forecasting in the short term. And then on facility for us is a way to tie it all together. So you'll find something that's wrong. You got to get dispatched. So we know everything that's in the fueling equipment. You can dispatch the work orders, first time fix is improved because you know what's happening in the fuel system. And for most of the folks on the phone, your fuel equipment is the largest source of risk and cost. So go to the next page here. So today, the perfect gallon quest has really 2 main parts. Is making sure that the fuel you purchased is the fuel that you dispensed and it's the fuel you've sold, kind of matching this financial gallon that you purchased, the physical gallons, lifted from the rack, delivered into the UST, dispensed in the vehicle, and the financial gallon recorded by your point of sale. We all know there's a fair amount of variance in that today. There's a whole set of people and process and technology focused on minimizing that variance. It's, people calling it wetstock management as well. We're trying, most people are good operators. They're probably between, 50 and 100 basis points there. We're trying to reduce that, save 30 to 90 basis points. The other part is frictionless fueling. This is our point of view around a fueling position at a retail, certainly a facility with fuel is a really important piece of real estate. How do you make sure it's functioning as well as possible? So the nozzle's available, the flow rate's good, the tank is pumping. Lots of things can happen to shut down a tank that are preventable that we have some insight on. So you can, again, if you pull all those levers, you can improve the customer fueling experience. And we have really good customer data that suggests you can, increase, 4 to 6%, or, probably 3 to 6% at the low end. Again, huge return. So we're going to talk about the analytics today that get you there, but we're going to focus on what's different as well. So the next page, what's different? People have been addressing these topics for a while. So Kurt alluded to a few of the things that are different with Titan. So we're a pure play cloud software company. We've been at Amazon for like 6 or 7 years now. So we know how to fully exploit cloud computing and high throughput IoT engine, where Kurt was helping us as an architect. So you kind of have this virtually unlimited scalability. You don't need equipment. The internet's ubiquitous. You can sample everything in a real-time manner, so you can get every probe height, every meter, 10 times a minute, which we do in some cases. So that level of granularity, the scalability of the data collection, and then the fact that we have CPU power to burn it, so to speak, helps us with the algorithms. Most of the algorithms in this space are coming from historical SIR vendors, which is pretty kind of low-end statistics, to be honest. And they basically gotten the data more often, but it's kind of like a SIR that was monthly, and they're doing it every minute. And so there's a lot of other algorithms out there and approaches that we can apply, machine learning being preeminent on there. I put the SVM there because that's my support vector machine background. But lots of techniques in machine learning. This is one of the ones we're using. We have optimization, there's control models. So there's a whole new set of algorithms, analytics can be applied to these problems that haven't been applied before. Part of it is because the compute scale wasn't available. Part of it is just the kind of same people have been doing this for a long time, and they have sort of they have a familiar set of tools, if you will, to kind of attack the problem. Versus if you come in and look at this new, we've come in and looked at this pretty new the last few years, kind of a new approach, best-in-class algorithms, data science, here's how we solve it. The final thing that's new and different from our perspective is we have an enterprise software platform. A lot of these issues, you need to not only be able to identify them, but triage them, maybe fix them remotely, dispatch somebody to fix them. There's a workflow component to this, which is really, really, really important. Also, you need to be able to manage everything that's going on, these alerts, alarms today, what's really important, again, false positive, true positive, priorities, workflow to get it done. And we have that ability to manage this. So if you're getting, alert because there's an unexplained fuel loss over here, and this is, how do I manage that to completion? How do I reduce the frequency and duration of that? So that's another important point. So with that, that's what's new and different at a high level. We're going to go into some of the more specific analytics, and I'm going to be the page turner for Kurt. And we're going to start with the tank chart, which is kind of core to everything.
Yeah, thank you, David. Yes, the tank chart. This is something that and you often have kind of a love-hate relationship with it because it tells you things that are kind of true, but not really always true. And sometimes they're really wrong, actually. And so the kinds of tank charts you get from the manufacturer, also called the strap chart, those are very, very coarse, right? They put in some water and measure it and then put in some more and see what they got in terms of translating heights into volumes, right? And that's pretty coarse, right? For the kinds of things we need to do, we want tank charts that are extremely accurate, but as well as precise. And those are two different things, accuracy and precision. Accuracy means the average answer is right, and precision means the grouping around the bullseye is very tight also. So we look at this picture of a tank chart here from Xerxes ECL. Many of you have these fiberglass tanks with hemispherical end caps. They have ribs in them also, and you see those kind of sticking out on the picture as well. And these things are seemingly capsules, but they're not really. There's lots of internal features there. You see they have pipes going in and out of them. There may be seams. If they're steel ones, they might have welds. Sometimes they're slightly tilted. They may deform based on if there's a truck standing on top of it or not. They get squished. All of this takes up space inside the tank and actually makes it hold less than it would otherwise, right? So often, your typical approach is say, well, let's use analytical geometry and cook up a model here, and there will always be wrong, basically. And they won't account for any dynamic features in the volume change as well. So they will always be wrong, and what we want to have is a very, very accurate translation of the height of the fuel in the tank to the amount of volume that it represents, okay? Next page, please. So a tank chart basically is this little function here, V equals F of H, right? There's nothing complicated about that, right? For any height of the probe, how much volume do I have? And you are all aware of the volume correction factors associated with temperature, right? So we might have F of H and T, perhaps, you know, to apply volume correction, and here are temperature corrected volumes as well. Most interesting, though, in the business of wet stock management and so on is the differential function, right? So we take the difference between one height and another height and see what the change in volume was. So this is important, for example, analyzing a delivery. How much did I get? What was I charged? Are those the same? Those kinds of things. Similarly, in fueling, do the transactions add up to what went out of the tank? Okay. So the kind of resolution that we're interested in here ranges from around 300 to 1,000 parts per inch, or equivalently metric if some of you are from Canada or Europe, right? You'll see those numbers there. We work in microliters. That's the unit we deal with, and this is an example of a tank chart. It looks smooth on the surface, right? It seems kind of smooth, but really it's not. They're a little crunchy, and that represents our ability to determine empirically a finite element model that represents the exact internal geometry of the tank, and that's what we do with our analytics. And those are driven by many statistical and, as we point out, machine learning methods for that. Okay. So these charts are extremely useful. They drive many of the other analytical products that we want to have here. Okay, next page, please. So when we look at the tank, we're trying to figure out what's going on in there. Well, they have states, right? And they can be idle. They're just doing nothing. They can be delivering fuel, depleting. They might be receiving a delivery. And in the case of siphon systems, the idle state is actually kind of two things, right? Because in the pair of tanks, there's the one that's the active tank or the service tank, and it always goes below the supply tank. And then after everything stops, those two even out over time, and the flow between one is equal to the flow to the other. And so that's what we call a relaxation phase that occurs in the siphon tank. That's also very, very important, actually, in a siphon tank. Okay, but there's lots of noise in these things, too. You know, the probes jump up and down all the time. You know, it's an analog to digital converter situation, right? And we have actually found this, you have large industrial operations near a facility, or there could be train tracks going by. There might be seismic activity, particularly out west. When the truck itself might park over the tank bed itself, these kinds of things occur. So we have to have lots of noise management stuff. Signal to noise ratio has to get enhanced in order to make sense of the data. So we want to make sure that what we're getting is meaningful measurement data, not just noise. Okay. So once we know where the tank is in terms of its state, and we have got the history of depletions and things like that, we can do many things. At a facility level, we can produce automatic meter mapping. We can find out exactly which meter goes to which product, and we can do that very quickly after observing the facility for a couple of weeks. Currently, right now, with one of our customers, we're doing a thing called accounting inventory reconciliation, or AIR, which uses the precision tank chart to analyze what's going on between transactions and depletions and deliveries and produce the inventory variance numbers necessary for compliance. And these are demonstrably better numbers. You are not out of control unless you really are out of control. So the whole idea of false positive on out of controls on your compliance requirements has been greatly minimized by that. Deliveries are also terrific at this point, too. We can look at the bill of lading, and assuming the bill of lading is correct, but sometimes they aren't, but usually they are. The racks are pretty good. We can get the delivery that we measure with our tank chart to line up with the bill of lading within a few points. And I'm not talking percentage points, I'm talking basis points. These are really great. Also supported by this chart is leak detection. So leak detection is like, well, you know, more is coming out of the tank than we're accounting for with our transactions. So there's a problem, possibly, right? And I'll get more into that on a later slide. Also, meter drift determination. We know the meters are wrong, but we'd like to know exactly how wrong they are, not just knowing that they are wrong, right? And they do drift along. That's typical, right? But we can use statistical methods to determine the meter drifts on each of the products and fueling positions. So that tells you, well, maybe I'm actually short here. I need to fix that because that's a compliance issue. Weights and measures might get after that. But if they're long, well, you're giving away fuel. So what's the confidence interval on the meter drift as well, right? These are things, do I need to address the problem or not? So we can provide triggers for maintenance activity on calibrations. You don't want to do a calibration if you don't have to because they're expensive, right? So we can figure that out and you can understand what's going on there. And lastly is anomaly detection. Anomaly detection is a big part of a lot of these machine learning approaches today. It works on usually unsupervised data where you don't really know what's going on, but you might know where it's coming from. And so we have anomaly detection models going on right now in the R&D department to identify over 14 different things that can be of interest from an anomaly perspective inside a fueling system. So let's go to the next page then. So David had mentioned SIR as a classic method, and there are these thresholds of the 0.05, the 0.10, and they're pretty coarse, right? And the 1995 guidance, it's pretty rough. Nobody does that. I mean, I actually worked at an Exxon station when I was in high school. My job was to stick the tank at the end of the shift. So I was always interested in, well, what do you do with that stick, Jimmy? He says, oh, I got this chart here. Well, things have come a long way since that, and that method really nobody would use if they had anything better to use. VIR is a method that's basically an accounting method. It's not really a leak detection thing, and it just does the analysis of deliveries and sold and what's in the tank, and it does depend on a tank chart for this, right? And that's where it often gets it wrong because the tank charts that are built into the ATGs are extremely coarse. Even some of the vendor-provided improvements to those charts are built up out of what I call stitched spline models that are not that accurate. They're coarse at like a 1-inch sort of layer level, and you will often get high variances out of those, or you may be missing variance that really is there as well. So Titan's Air, we released that last year. It's a terrific improvement on this stuff. There's no special hardware for this as well, which is great. And it's based on our tank chart, which we developed. It takes us some time to measure and collect all the data to make the tank chart. Once we have that, then we can start using it, right? And it provides excellent inventory control and reconciliation for us. And that's really one of our first, analytical products that we're delivering currently to clients. Okay, next page, please. So leak detection is always interesting because when it happens, a leak, it's bad. And you'd like to know as quickly as possible that you have a leak. And, the typical stuff from the National Working Group on Leak Detection Evaluations sets the threshold at basically 1/10 of a gallon per hour. And that's a lot, really. It's a pretty coarse measurement. A lot of people are able to get under that bar in terms of getting a certification for it. But really, we'd like to know more, right? And we'd like to know about smaller leaks sooner. And so with the perfect tank chart in hand, we can then do this reconciliation, similar to what the air does, but actually a little different because there's more attributes available and there's a larger model involved for leak detection. But what it does here, and this is based on the same protocol that the NUI is how they pronounce that acronym, uses for evaluations. And so, for example, here's a 0.025 gallon per hour leak, which has been simulated, which is the same thing NUI does. This is actually out of 900 months of activity on this particular site for which you have real data that drives the simulation. These are all what we call trace-driven simulations. And what you see there is, of course, if you did nothing, right, that's the orange line. If you just let the leak run, it's going to keep on running up, right? But there is a chance that we may detect it, right? And it depends on where it is, when it is, and there are statistical properties and variances associated with these leaks and so on. But out of these 92 leaks, they get detected, some sooner than others, okay? And this thing is called the average run length, basically, if you're into statistics, right? But what it tells you is that, well, okay, for the NUI certification, I need to find it at the 95% level, which is roughly going over and down on that chart around 125 hours is the certification level. So how much leaked out? Well, about 1.5 gallons. that's great because this is a kitty litter problem, not a major environmental remediation involving removing the dirt and all this other stuff and, you know, monitoring wells and all these things. No. So that number right there, and you see how it tapers off, right, the black line, the maximum undetected leakage is less than 2 gallons, even if it goes out to 144, 168 hours. But notice where's the 50% detection line? It's only within 2 days, okay, a little more than 2 days, 48, 50 hours. So that's really important. That's your expected time to detect right there, about 2.5 days. Okay. Okay, next page, please. Yeah.
So I'm going to talk about this a little bit. It's not necessarily, we're kind of departing a little bit from the analytics world. I would just mention on the leak detection, again, the market now is like a 0.2. We're at 0.025. Our time to detect is, you know, really quickly. So it's an order of magnitude improvement. You know, Kurt's working on getting the official certification done. We've done a lot of work there. So more to come there. Getting back to one of the agenda items, talking about customer fueling experience, we have a point of view on how to improve it. We call it frictionless fueling. It requires both analytics and a platform. So this, while the analytics are important, probably more important here is the fact that you have a collection of tools to diagnose them, as well as a platform and workflow to deal with them, because there's lots of these issues. Some of those are pretty easily observed. How do I prevent them? How do I reduce the time before I detect them? So in the kind of orange color are the levers that we're addressing through our frictionless fueling product. And really, it's you know, flow rate, nozzle availability, the experience. Our customers have found that the previous experience at a fueling position has an impact on how many fill-ups happen per fueling position. And then the tanks that shut down, this is PLLD and non-PLLD. This is related a lot to the preventable. So there's some that are normal shutdowns, you know, fuel's not there, but a lot of them are preventable. So it's focusing on these preventable tank shutdowns, which have huge impact to your operations. So we have a set of solutions around fueling positions and tank shutdown, and the platform, and we'll demo this later with Clay, allows you to identify the issues, filter out the noise, really important, like flow rate, what's really a bad flow rate versus what's, you know, something else. We can triage it, we can fix it, tank shutdown, for instance. And then we have workflow to make sure we dispatch it and first time fix, whether it's our own work order system or it's another's work order system. We have an API. So it's this kind of detection, triage, you know, workflow, dispatch solution that allows you to get to, let's say, a 3% improvement in volume. And you can kind of go down this logic tree here and sort of see some of these things. Obviously, we can't impact. We can't impact how many fueling positions are at the site or the gallons sold. We can impact the number of fill-ups, though, per fueling position. We could similarly. So these are the kind of, again, the orange are the levers we can impact with the solution, where customers have used our software to impact it positively. And there's an enormous improvement in the gallons per month there. Again, at some level, it's very obvious that if the fueling position is not available or if the fueling position is suboptimal, that's detrimental. In the world of millennials and the world of experience, the experience economy, I think is in year 20, the experience you get at a fueling position is important. Some people will complain loudly about slow flow. If they can't fuel, they leave and they go across the street. They typically don't go to the same. So it's just a lot of bad experiences drive behavior more so now than ever. People want that online experience to be offline. So again, it's better to see what that looks like, but there's a lot of pieces to improving the fueling position. So the next page, and we'll touch on this, it's kind of a busy page, talking about managing inventory and forecasting. So there's a point of view, and this is where I'm going to play data scientist on TV because, you know, we could really get into the weeds here. But at the end of the day, people today are managing inventory when they don't have to. They can control inventory. The data is available on a much more real-time basis. There's models available to kind of optimize. So it's a combination of getting the data really real time, as well as running some optimization models based upon certain policies. It's like a control model. So here what we have in the upper left is we have an inventory managed, this is what this client did. How many, delivery orders were there? What was the average delivery size? We did a control model based on a policy that had 12 orders with a much higher average delivery per order. So it's a much more profitable operation here. So you have, if you think about it, right, just fewer deliveries, each delivery is greater. Those are drivers of profitability. Most people in this industry, we've basically you're generating optimal proxy orders to help your dispatchers dispatch. To be honest, most people are not ready for that level of thinking, so far away from where they're at. So we start with minute by minute depletion models. So we can dramatically improve the forecasting function today because we can actually understand depletion at the minute level, and then you can use that to forecast in the future. But I said on the R&D side, we've done a lot of work in this control model optimization world. It's just that people like it. It's kind of, so most people are dealing with kind of fires over here, and they're not really ready to optimization yet. They're trying to kind of fix what they have. So, but we'll show what we have here in terms of how that plays out into the software. And we can certainly dive into this more at a later time. It's kind of some interesting stuff in terms of modeling. And then, so finally, let's talk about customer results. So I'm going to set this up. I'm going to stop sharing, and Clay here is going to go into the details here. So we have some, we have customers using this. We have examples. On the high definition product, we have a situation where someone reduced variance by 30 basis points. They had about $500 million of fuel supply costs and $1.5 million in savings. Again, the names have been changed, but the improvements are real. And so we use perfect tank chart delivery in the air. Frictionless fueling, we had a situation where someone increased fuel sales by over 3% per site, and that translated into over $2.2 million in fuel profit. Now, how you get there, this is 245 sites, averaging 110,000 gallons per site, 3,300 additional gallons, and a fuel margin of 23 cents. That's historically pretty good. These days, I think it's much, much greater. But again, you would plug in your specific situation to these lift factors, if you will. There's big dollars here. And then on the delivery planning, we have something in process, not quite ready to put numbers on it. But the minute by minute depletion models and kind of how you improve forecasting, pretty substantial. So I'm going to stop my sharing here, and then Clay, if you want to take over.
All right. Give me 1 second here. Where'd you go? And share. All right. So again, thank you for everyone for joining today. I'm going to start at the high level and dig into each one of these categories as we run through this. What you're looking at is basically a fuel dashboard where we're talking about all the elements that impact frictionless fueling at a site level in regards to runouts, inventory variance, dispenser or flow rate items. Each one of these sections, such as like the runouts, I can click on the gear and go into which grade and how many hours that I want to have on hand, or as far as my runout projections. So everything can be, brought to a dashboard to be able to see those things of interest really rather quickly. When we go to inventory variance, I want to kind of hit that first because when Dave was talking about what does a better tank chart truly mean for the individual? Well, one is that the inventory levels that you're going to get from the gauge will be more accurate. Often we find faulty programming the gauge where you have 25 inches of tilt or 40 inches of probe offset or some thermal coefficient, which really impacts what inventory levels are being reported. These things, of course, not only impact your inventory levels that you're dispatching from, but it's also impacting your inventory variance when you try to reconcile your inventory books. So what I'm going to go is I'm going to go into this site. This is an actual site. Of course, names have been changed. If I go to April, I'm just going to pull up BR. Now, this is what's coming from the gauge. This specific site is in liters. It is also running AccuChart. So this is like the best product of Veeder-Root as far as the AccuChart in the gauge. And it's got an inventory variance of 354 liters for a month, which is not bad based on what you're seeing. It's within a passing threshold. And at this threshold, I've actually set it to 0.5%. Now, when we do the same analysis with the better tank chart, instead of the tank chart that's in the gauge, you run the different numbers from the raw data based on the high-def tank chart that we do. There's a couple things that really starting to show out. One, our variance for that same period is 30 liters. That's less than 8 gallons for an entire month of variance, as opposed to the 300-something liters that the other systems would use. The other thing about the high definition is you'll notice there are twisty ties and little expansion sections over here. So when there's a problem at a site, not only do you have the tools, not only do you have the tools to see your inventory variance, but being able to dig into the actual transactions that occurred, which part was the variance, where did the source come from. So here you can see negative 64 liters happened between 3:22 p.m. and 3:45 p.m. Now with this, because you're able to see this level of detail, you're able to get into the deliveries. So this delivery that's posting here is the delivery that we, to the air calculation, was within like 2 liters of the actual bill of lading, as opposed to what the gauge was saying from the delivery there. And if you go to our bill of lading section, this is where we can actually compare. I'm blow this up so everyone can see it. This is where you can compare the bill of lading and delivery amount versus what the actual delivery was. Now, this shows the delivery variance of where we're out. So even though the gauge may say one thing, the BOL says another, that variance is very important to track and impact your inventory variance at the site. Your delivery variance is a huge cause of issues at a facility. So being able to get a more accurate delivery, being able to get a more accurate inventory level, all this plays into the error calculations that we're doing at a facility level. Is there anything else you want me to add there, Dave?
So I would just mention the kind of twisty ties, if you will, is kind of an artifact related to this error, accounting interval reconciliation. And if you're an analyst or you have a team of analysts or fuel accounting folks trying to dive into the variance, it's pretty helpful. And then on the right, it tells you that you're out of control, right? This is the notion of a control limit, a control chart, process control. So you're out of control. Again, it's useful for the diving into something happened. Even with the better tank chart, it's not always going to be perfect. So anyway, it's just FYI.
Yeah. And then to that point, Dave, when you're looking at the control limit over here, this is where you can see where you're going in and out of your variance, specific to the actual time of day. So I was within control bounds, and then I fell out. Well, why? Well, when did it happen? So now I have the time frame to go investigate. We can look at what dispensers, what fueling positions were actually, active during that period. We're going to go back to the fuel dashboard and kind of show you, because those are the inventory variance, tanks that are out of variance. Then you can look at, calibration and unexplained loss, the anomalies, if you would. And all that revolves around the error detection. When we get into the dispenser flows, like the no flow, which is the things are not working, that's going to show you on your dashboard. You can immediately go to it, see which sites are actually not flowing, which fueling position meters may be offline. This is where, when fueling positions are not available, that impacts far greater, as well as, brand, recognition, brand damaging. If the things aren't running properly, there's a severe impact, not just to the day-to-day sales, but brand recognition is also a part of that. So here you can see which fueling positions, which facilities that have not pumped fuel and where the issues are. Same thing for slow flows. Currently, I don't have any slow flow dispensers, but we can see which ones are trending over the past 7 days currently. And so this is where you have the tools to actually dig into your fueling positions. Now with flow rate, when a flow rate goes below 7 gallons per minute, we've noticed that, that's kind of like the minimum you ever want to do. By keeping filters change placeless, filter replacement, constantly, or when it's below that point, it raises the flow average, it improves the customer fueling experience, and that's a big shift in percentage throughput. Anyway, I'm going to go into the runouts. You'll see that there's a
Before you go there, I think that the other point here is you can identify here are the issues, and you can also then deal with them, right? There's a workflow piece of this that we're probably not going to be able to get into today, but okay.
Well, knowing's half the battle. So being able to see the issue is one thing that we can definitely report, send alerts, give a report zone, notify you. And then we also offer workflow tools to be able to resolve those issues, to ensure that that issue that you're seeing is resolved the proper way.
Yeah. So again, we have a whole activity workflow work order piece of this, but let's talk a little bit about delivery planning, and then let's make sure we have time for questions. So maybe wrap it up in the next 3 or 4 minutes.
Okay. So on the delivery planning, what you're looking at here is all the tanks together. You're also going to see that your product that's going to be running out of fuel first is what's going to be highlighted in your product column. So when I look through this, I can also see what's my capacity, what's my safe capacity, how much fuel can actually drop in there, what's my volume and my safe ullage, and if I do not get a delivery, what is my inventory level going to be for that tank if I do not get a delivery in the next 24 hours? In this case, it will help you prioritize which ones are going to be most impacted without the delivery. If you look at the runout time in hours, this is not a runout time like a lot of systems use, where 0 is used to calculate the runout. This is when you no longer can pump fuel. This is the low product level limit, or the where you hit the dead stock, where there's no movement in that fuel. Other items of interest on this page, besides just the runout, you can also look at which terminal is associated to that tank, as well as the closest terminal and the trip time that it would take. So there's a lot of other calculations here. If I click on the actual twisty tile on the left, you'll see that it'll actually expand out and show me my tanks, show me my volumes. When I look at this, I can also mark when I have already delivered something. If I've scheduled a delivery for this facility, I can mark that there's a delivery already in progress, that I've already dealt with that facility. And when a delivery is picked up for that tank or that product at this facility, that check mark goes away. So it's already taken care of. When a delivery shows up, it removes the check mark. It goes from there. Now, in this delivery forecast that we're doing, this is the minute by minute, the same day, same minute for the past 4 weeks is used to make the projection. And if I cast the projection into the future, you can see there's my actual curve where it's going down into the drop down. So here you can see which tank's going to be running out. You can prioritize that based on the run out time here, and I can even forecast graphically what that looks like. At the site level, I can actually dig in to the inventory and graphically see visually what the inventory is doing, and look at my forecast into the future as a dotted line in my projection. Okay?
All right, I think that's good. So I think the key points here, I mean, this is to some degree, delivery planning. The key analytical here is this minute by minute depletion rates. So we're able to be extremely accurate in projecting forward, because we know exactly what's happened minute by minute for the last 4 to 6 weeks, every minute of every day. It gives you just a better baseline, better data, better forecast. I think it's a good improvement to start with before you get into the world of optimizing proxy orders. So let me take this screen back.
Okay. Let me stop. Are yours?
Yep. And then I'm going to go And let me just kind of, again, these are we talked about, these are the analytics results, and we can dive into those more subsequently. Questions, type it into the Q&A window. We'll give some people time to do that. I'm sure there's some questions already available. So again, type the questions into the Q&A window. And then I guess I have my Chief Revenue Officer, John Donnelly, and team on here. John, are there any questions that we've gathered so far that you want to send to myself and Kurt?
Yes, actually we have a few, and thanks everybody for joining this afternoon, and thanks to Dave, Kurt, and Clay for giving that overview. It's been great. The first question actually comes from the kind of the folks out there in the world. It says, what are the data sources that Titan is using in order to get the flow rates to the gauges? Like, what data sources are coming into the software to allow that to happen?
Sure. I think the key data source, the key requirements are probe heights, and then totalizer values, and then however we can get those. The easiest way for those to get those today is probe heights or ATGs. Inventory gives you probe heights, so we're sampling that, several times a minute. And then the totalizer values you can get with an EDEM or point of sale feed, and we're getting them both ways. If you have an EDEM, again, all the new ATGs already have EDEMs. The older ones, you have to have them. Or if you have the point of sale feed, as long as we have a clock that's in agreement, we can get those. We're getting those from some of our large customers, a direct point of sale feed.
Great.
I should add one thing to that too, David.
Sure.
Is that it's often the case that that data by itself may give you a bad number on a flow rate estimator, because what you're trying to estimate is the optimum flow rate out of that fueling position. So if somebody goes in and the nozzle clicks off while they're in the C-store, and then they come back out, and then the time versus the amount of fuel, it's going to underestimate the real flow rate that you have available. And so we have statistical processes to produce the best estimators of the maximum flow rate available in that dispenser. And that's really what we're controlling for, is the best or current maximum versus the true maximum. And those are two different numbers, as Clay points out. 7 is a good number. Most can actually go 9, and that's based on some physics of the fuel and other things like non-turbulent flow and other stuff. So I just thought I'd amplify that a little.
Great. Thanks, Kurt. Next question is, if I'm using the software Clearview now for fuel management, can you explain in more detail how you guys think perfect gallon is different from what we have with Clearview now?
Sure. Let me just put Clearview and Warren Rogers and Light O'Brien kind of in the same bucket. They're serve vendors historically, and so there's a difference at the fundamental algorithm level, right? So those are all serve vendors. I think I think Warren Rogers kind of created it, and then the other ones copied it over the years. But they're serve vendors. They're using an adaptation of serve processing, and you can look at. And so we have a different approach, different algorithms, machine learning, optimization, that kind of stuff. Ours is better. Now, that's just me saying that, but we will have the proof here shortly. And those serve vendors have kind of a 0.2, 0.1, kind of leak detection. We're going to be 0.025 with the time to detect. That's probably 1/10. So kind of our algorithm's better because we're kind of doing it differently, kind of looking at it fresh. And the second point would be, most of those folks are giving you reports and emails and maybe a dashboard. And kind of the underlying software platform we have gives you the whole process management, workflow management, remote triage. So you're able to manage the issues. And for a couple of them, we even get the results. We're able to plug and play with whomever. Like some of them actually, a lot of them still provide SIR. So the SIR results come into our system, and they use our system to manage workflow. In the world of wetstock, it's a similar thing. There's issues, there's items for attention, and we have that workflow. So again, the algorithms are different and they're better. And then the underlying platform to manage the exceptions is more comprehensive in actual real workflow.
Okay. Next question is, does the company Veeder-Root actually resell Titan software products today?
They do. So I think if you're familiar with Inform.net, that's our ATG polling engine. They're reselling it. It's a version of our ATG polling engine, and they're reselling it. So we have a lot of, I guess the point, why should you care? We just have a lot of expertise in getting data, and they resell it, and it's our software and our IP.
Okay, great. And then next question is around kind of what type of ROI are customers actually seeing from using Perfect Gallon today, or what can they expect from, kind of an implementation initially from what they were, let's say they're using something else before and now they're using Perfect Gallon. What's an ROI look like? What can they expect?
Yeah, so here's where the ROIs are kind of so large that I don't even want to say them because it's like, it sounds ridiculous. But I mean, our pricing is we're charging market pricing, so we're better, we're faster, and we're the same price or even a little cheaper because we're software only, and we're not in a position to give you a bunch of analysts. We're giving you software, so we're kind of the better, faster, cheaper. The ROI is kind of off the charts. So that's not a great answer, I know, but it's like you pay for it in a year kind of scenario, right? And there's not a lot of upfront investment here either, right? So we're not, again, our approach would be no new hardware, give us connectivity, we get the data. The ROI is enormous, and I do have some numbers, but if I threw those out, they would seem ridiculous because they're so high.
Well, I think you're right, David. Another point there, too, is that for most companies, the way their accounting works, this is mostly an OpEx, not a CapEx as well.
Great. Next question is, does Titan offer trials? I guess I can answer that. So the answer, obviously, is yes, we do. Like in every situation, if someone's looking to get their hands on the software and it's the right environment, we'll absolutely do that depending on, what the situation is. So as Dave said, we're offering a software subscription. It's a SaaS model. So it's very easy for us to set somebody up, give them a login and give them access to the software to try some things out. We just ask them to kind of work with us on kind of key success criteria and what they're looking to kind of accomplish, what they're looking to prove, and we're happy to do that. Next question is, how does your software modules compare to the fuel visibility module that Insight 360 has in the market now, or to Halo?
Yeah, so I think for Insight 360, we have something that can compare directly. We would just essentially dial down our software a little bit to be kind of basic visibility. So we can, we offer a lot more, but I think, that visibility is a nice sort of beginner kind of, it says visibility for a reason, right? So it's just seeing stuff. You're not managing it, you're not optimizing it. So we can show that. We have something that's directly comparable. So you just we'll just sign up for those specific subscriptions. And then for Halo, my understanding of Halo is a rewrite of what FuelQuest was, which is a full-on logistics, financial management, and we're not doing logistics and financial management. We kind of insert ourselves into the world of forecasting because that's an analytical intensive thing, and we think we have this. It relies on really good data from ATGs and relies on analytics, and we think we're better than the market in both getting data as well as the analytics. But the rest of the workflow and the financial piece of it, and creating loads for trucks and drivers and managing trucks and all that stuff, and in cab, we're not doing that. We do interact with those folks, so we can be the data broker for people like Halo or Telephone or whomever. We can also obviously provide a better forecasting model than they can, we think, and so we can kind of interact with each other. But we're not doing the. If you have a carrier managed inventory scenario, we could add a lot of value. But right now, I don't envision us actually creating something for managing trucks and drivers right now.
Okay, great. So that's all the questions I've seen so far from the folks on the webinar. But obviously, as Dave said, we're leaving an email here, customer.success@titancloud.com. So we have a full go-to-market team handling all of our customers and things like that. So if you have further questions, please email those to that address. And I think for those that attended the webinar, there will be a recording available as well. So that's it for the questions on my side, Dave.
Well, I would just like to thank everybody for taking time out of their day, in their pajamas, their house, wherever you may be. We're lucky enough in Tennessee where we're actually a fair number of us are in the office. But again, thanks again for taking time out of the day. Stay healthy. Hope to have some further conversations with everyone. Thank you.
Thank you.
Thanks very much, everybody. Thank you.